that you mentioned, Mr. Margus, is that there's a different type of atmosphere at the top tip than there is at the bottom tip, and so there's additional torque and shoot.
You've quoted a couple standards. Are you familiar with ISO 1996-1971 recommendations for community noise limits? They're recommending in rural areas a daytime limit of 35 dB, an evening of 30, and a nighttime of 25. In suburban, it would be 40, 35, and 30. Why did you not quote that standard?
Because that standard was superseded by the EPA Residential Noise Guideline and also by the World Health Organization about 2 decades ago. So that standard is no longer in force in the International Standards Organization.
So the WHO in this quote recognizes a special place of low frequency noise as an environmental problem. Its publication, Community Noise by Berglund et al. In 2000, makes a number of references to low frequency noise, some of which are as follows. It should be noted that low frequency noise can disturb rest and sleep even at low sound levels, so your DBA would not be accounting for those low frequency noises. That would have to be on a C scale, I think. For noise with a large proportion of low frequency sound, a still lower guideline than 30 dBA is recommended. When prominent low frequency components are present, noise measures based on A weighting are inappropriate. Since A weighting underestimates the sound pressure level of noise with low frequency components, a better assessment would be to use C weighting, and it should be noted a large proportion of low frequency components in a noise may increase considerably the adverse effects on health. That's all from the World Health Organization.
Yes, let me address both those issues for you. First of all, the C weighting scale is used when there are sound levels above 90 decibels. The A weighting scale represents how our ears respond to sound in the normal range of 30 to 90 where we hear no sounds. That's why the numbers on the chart say decibels A, that's the A weighting. And the A weighting scale is used universally for all community sound studies. C weighting is the way the human ear responds to very loud sounds, those that are above 90 decibels. So it is inappropriate to ever use the C weighting scale in regulating a sound source that's less than 90 decibels. I can tell you that as an expert in acoustics. Now, there is language in the World Health Organization's report, and it actually comes from, it's copied from the IEC 61400-11 standard for wind turbine noise, where they propose a threshold test for whether a particular wind turbine model has low frequency sound that would be great enough to cause annoyance. It's a threshold test. It's in IEC 61400-11 Appendix A. And that test is that you take the decibels on the C scale and you subtract off the decibels on the A scale, and you look at that difference. And if it is greater than 20, then further studies for low frequency sound are recommended because that particular turbine has the potential from significant low frequency sound components to possibly cause annoyance. It doesn't say it will, but it possibly. The Vestas V100 turbine is one of the more friendly turbines on the market today in terms of having relatively low frequency sound. It does not pass that threshold for low frequency sound. So by the international standard IEC 61400-11, it does not have the potential for annoyance due to low frequency sound components.
Thank you. I suspect, since you're referring to American standards, you're not going to like these references. Australia uses the higher of 35 dBA or L90 plus 5 dBA. Denmark uses 40 dBA. France uses an L90 plus 3 dBA a night. Germany uses 40 dBA. Holland uses 40 dBA. In your expert opinion, is there something different about the ears or the vestibular mechanisms of Europeans that somehow doesn't apply here?
Well, that was a softball pitch. I think there's quite a bit difference between Americans and Europeans. And I guess I would start off by saying I didn't realize that the United States were a member of the European Union and subject to their rules. But
My mother was born in Austria, so.
well, my grandfather in Norway. But to your question, there is something different in some of those countries, at least. In most of the European countries, the new wind energy development is primarily offshore. It's in the near offshore area. It's in the 1 to 2 mile area offshore. They aren't building a lot of wind turbines on land for a number of reasons. They don't have the space. And in those countries, the Scandinavian countries and Denmark and so forth, where they're doing offshore development, and Britain is primarily an offshore development country as well, they have adopted limits that are far more stringent because that they can and still do wind development. That's the simple answer. If those same limits were applied to onshore wind development in European countries, it would preclude any wind energy system.
Anything else?
Okay. So rural area is 35 decibels, correct? Is that, I think one of your earlier charts had. But we're proposing you're recommending proposing a 45, correct? So, and if everything's twice as loud, so you're proposing, I guess 45 is supposed to be twice as loud as 35. Or did I lose and misinterpret something? So, is 45 twice as loud as 35?
45 is twice as loud as 35.
Okay, so we're proposing a nighttime noise twice as loud as what's outside?
But it's a little bit of apples and oranges. Bear with me for a second.
Yeah, fine, good.
Okay. So let me take you back to average sound levels. Let's just look at the average sound level, the green line, because that's what we all do in a quiet rural area, and assume there isn't a lot of traffic, which is most of our good times. 35 when there's very light or no wind. But the average sound level, when a wind turbine would be turning at maximum power, which would be 22 miles an hour over the hub. And that means approximately 15 miles an hour down near the surface. Would be just about here where I have my finger on the right-hand side of the graph. So the average sound level would be in the 40s on a day when you have a steady 15 mile an hour wind. You know, steady 15 mile an hour wind, that's when you go outside and it's blowing in your face. Okay? A steady 15 mile an hour wind is what you're going to need down near the ground to have something 20 to 25 miles per hour up at the hub. That's what you need to really make the turbine crank out at its maximum power. The reason I'm talking about the maximum power condition is because that's the one that's going to be limited by your regulation. If you set it at 45, it's going to limit the operation. It's going to limit the spacing and the location of these turbines so that under the maximum power production of the turbine, it can't produce more than 45 decibels. When the turbine is just starting to turn, it'll be about 7 mile an hour wind near the surface, just about the middle of this graph. Okay, so the average sound levels might be in the high 30s, let's say. So your question was, well, if we write an ordinance that allows 45 decibel limit, aren't we automatically allowing the average sound level to jump up 10 decibels? And the answer is, you might on a certain day at a certain location, but in general, you're not going to be doing that, because when the turbine could possibly produce 45, its maximum power, the existing sound levels just from the wind noise are going to be up in the 40s. When the turbine first starts turning, as I pointed out before, it's going to be about 34 decibels at 1,000 feet, just to pick a reference distance.
Why is there a difference in noise? Because the two blades turn at the same speed.
The blades turn
Whether
at-
they're low, then it's the same speed, so why is there a greater noise?
No, they turn